In this lesson I'm going to walk through 2 proofs with you, and then you'll have those for your notes, and then you'll use all of your notes in class to work on some more proofs independently. So here we have an image, and we're given all this stuff. We have AB is perpendicular to BC, so I'm going to mark this diagram up as we go. We have BC is perpendicular to DC, and then we have AC. AC is this. AC bisects DCB. So this angle here is what's being cut in half, this right angle. And then we have the same thing, I skipped over this one, we have DB bisects ABC. So these corner angles are getting cut in half. So here's how I'm going to mark them. I'm going to mark the left-hand side with just a single arc, and then the right-hand side I'm going to do double arcs. What we'll have to do is we're going to prove that both of those angles are congruent to each other. So I'm trying to prove that the bow tie triangles are congruent. And we're going to use what we know about vertical angles and perpendicular angles, and I think we're also going to have to use isosceles because we really don't have any other way to get any other angles or sides. So here we go. I'm going to start with, let's do the bow tie first because that's the easy one. I'm going to have angle 1 and angle 2. So just to start off with stuff you know. I usually look for either vertical angles or reflexive just to kind of get you warmed up and into it so you're not freaking out over a proof that you think you can't do. Angle 1 is congruent to angle 2, and that's because vertical angles are congruent. Okay, so we have an angle. The next thing we're going to do is we're going to say the 2 right angles are congruent because perpendicular lines form right angles and right angles are congruent. So we're going to write all that. We're going to say angle ABC is congruent to angle DCB. So here's our statement. Perpendicular lines form right angles, and right angles are congruent. So now we have the 2 angles congruent, but we also know that we're going to use the definition of an angle bisector. So we're going to say these 2 angles are congruent and these 2 angles are congruent, and from there we can get these angles congruent and these angles congruent. So here we go. So we're going to say that angle ABE is congruent to angle EBC, and angle DCE is congruent to angle ECB. And definition of an angle bisector, or bisector divides an angle in half. This was just shorter because I'm running out of room. Now we can say that we're going to get these other pairs of angles congruent. So I'm going to say that because halves of congruent angles are congruent, we're going to write a line and say all these angles are congruent to each other. So I can say that angle ABE is congruent to angle DCE. And in the same line, I can say that angle EBC is congruent to angle ECB. ECB, because halves of congruent angles are congruent. Here's what I have. I have my second angle, ABE. ABE is congruent to DCE. So there's an angle. And now I need a side. Well, I can get a side because I have these 2 angles congruent. In a triangle, sides opposite congruent angles are congruent. And that's going to be my angle side angle. Okay, so I can say EB is congruent to EC because in a triangle, sides opposite congruent angles are congruent. That's enough to say that my triangles are congruent. Triangle BEA is congruent to triangle CED, and my reason is angle side angle. So in this proof we used vertical angles here and got these two angles congruent. We started with 90-degree angles, so we got the big angles congruent, and then we broke them up and we said halves. We knew that these two were congruent and these two were congruent, so these are halves and these are halves, and then halves of congruent angles are congruent, and then we use that to get the sides congruent. So angle side angle, using a lot of different reasons that we haven't looked at too much before. In this proof I'm going to show you how to use the addition property to get some sides congruent. So here we have our diagram, and here we have all this given stuff. So AB is perpendicular to BC. I'm going to mark it up. AB is perpendicular to BC. DE is perpendicular to EF. BC is parallel to EF, so that means these two lines are parallel, and AD is going to be a transversal. And then AF, this piece, is perpendicular to DC. So I have all my given written down. And what I'm going to look at first is getting AC congruent to DF. And here's how I do that. I have a little bit of reflexive in here, right? FC is going to be congruent to FC. So FC is congruent to FC. That's reflexive. And then I talked about this addition property before. Because the parts are congruent, we can say the entire sides are congruent by addition. So I can say that AC is congruent to DF. And all you have to say is addition, because you are adding congruent things together. Okay? And then, so that's our side. All right, so what else we have? We have right angles. Now, if you look at this, some people, some kids try to do hypotenuse leg, and yes, we do have the hypotenuse, but we don't have any congruent information about the legs, so we can't go that route. So instead of trying to claim right triangles, we are going to say that these angles are congruent. So I can say that angle B is congruent to angle E. Perpendicular lines form right angles, and right angles are congruent. All right, so that gives me an angle. The last thing I have is the fact that we have parallel lines. So when you are given parallel lines, look for an angle. And if you can see, here's my Z. So what that tells me is I have alternate interior angles, and they are going to be congruent. So I can say angle BCA is congruent to angle EFC. And the reason, with parallel lines, alternate interior angles are congruent. You can't just write alternate interior angles. You have to say this. With parallel lines, alternate interior angles are congruent. And that's sufficient. That's my other angle. So in this case, I don't have angle side angle. I have angle, angle, side. Okay, so that's enough to say triangle ABC is congruent to triangle DEF, and it's angle, angle, side. So you're going to practice a lot more of these in class, but use these as a model. This is a good one to show you how addition works and what we do with parallel lines.